In this tutorial, we'll be securing Azure SQL Database and server. We'll be using data discovery and classification with also like Azure Defender for SQL. So let's dive into the portal. I have already logged into the portal. Let's go to Azure SQL Database. So if you are already familiar with SQL databases, how to create it and how to create table, you can skip this part. But as for this demo, just like my other demos, I'll be creating everything from the scratch. That is, even a beginner can follow my tutorial. Let's select a resource group. I'll be selecting one resource group where my Azure SQL database will reside. Next, I need to name my database. Let's name the database Cloud Guru Amit DB. Since there is no server, we need to create a server. Let's click on new Cloud Guru Amit DB server, and the server will reside in the location east to west. Looks good. For authentication method, I'll be I can use SQL authentication just the classic way, right? Let's give it a username and password. So let's give in the admin. Please keep this credentials secret because as a DBA or a security admin, you want to keep these things as secret. Don't want to share these credentials, otherwise you might land into trouble in real life job. So let's click on OK. Let's go down and we'll select development. Since this is just a test environment for us, let's configure the database size and all. So I'll be using basic for less demanding. Click on apply to save some cost. For redundancy, I don't need anything. I'll be selecting locally redundant backup. Looks good. Let's proceed to create and review. There is one important thing, like in networking, I need to enable public endpoint so that I can use a query editor. Otherwise, will be facing trouble when to create while creating table and while inserting data. Like those won't be available, right? So those things we need to especially in the networking tab, we need to check these things. Mark it as yes. Please note this thing. I'll directly go to review and create because everything looks good. I'll go to create. So our deployment is in progress. It will take some time. So till that time, let me dive you into the SQL queries. So we'll be creating basically two tables. One is the employee table, which consists of these columns. We'll be inserting some dummy values into these employee table. If you look, next we'll be creating another table, that is employee underscore Cloud Guru Amit, which will be having these columns, these many columns, and we'll be inserting some dummy values as well there. So two tables, two dummy values will be inserting. Let's go into the portal. Alright, after 5 minutes around, our deployment is complete for SQL database and server. Let's quickly go to the resource. So we are at the SQL database. Let's first go to the resource group as well. So we have these two. I'll quickly duplicate this tab because I'll be needing this in a while. So now let's go to the SQL DB first. If we see here the query editor, if we click, so it will be asking for password. Now I need to enter the password. Let's click on OK. So I'm in here. So now let's fire this commands, that is I'll be creating a table then inserting values. Let's do it one by one. So I've created one employee table and now I'll be inserting these dummy values into the employee table. Let's click on paste and run it. Values got inserted. We can see the success message. Now let's create another table named employee underscore Cloud Guru Amit. Let's go back. I'll be opening new tab and pasting this. Let's run it. So our table got created because we got a success message, and now again we'll be inserting some dummy values once again. Let's open another query tab. Let's paste it and click on run. So okay, so there might be some problem with my query. Alright, I got it because start date I have made some modification because it's not start date, it's actually date of birth. Let's copy or let me type it out, date of birth kind of thing. Let's run it. Yeah, it got succeeded now. So it looks good in terms of like inserting datas and creating tables. So I'll be quickly running the select statement to validate what's there in the tables, right? So let's run this first one, Cloud Guru employee Cloud Guru Amit. It got these values. Let's check the other table. I'll be firing one select star again. Let's fire it. So it got these values, right? So from here we are done with the SQL part. Now let's start the actual tutorial, that is will be securing this SQL database. So let me flash the architecture diagram where we are. So we have successfully created SQL database and SQL server. Our tables are ready, everything ready with the data. Now let's begin with securing this using first step will be to enable Azure Defender for SQL. Let's go to the portal. We'll be finding under the security tab. If you look, Microsoft's Defender for cloud. If you look here, we got the enable button, and here if you look, there is the thing called configure or something. Let me first enable it. We'll be getting or enabling some buttons as well. Alright, we got a success message. Now if you look here, enablement status enabled at the subscription level, we got a configure here. So we can click on the configure, and if you look here, so it shows the billing for Microsoft Defender for SQL, how much it cost in INR per server per month. So this is all we can view it, right? So let's go back now, one step back. Now we'll be using data discovery and classification. So let me give you a brief idea what is data discovery and classification. If we look at it is actually self-explanatory. Data discovery, so it's meant for discovering and classification data and putting labels in the sense, let me show you the table values. Let's say we have date of birth, this contains one PI data, so we'll be marking or classifying this data. First name, similarly I can again, let's say I've made it PI data, first name. So these things we can classify. We'll be seeing everything, and now what values we have. Let's go to classification. So under classification, if we can here add classification. So I've got my tables listed. We can select our schema, the table, both the tables which our database has. We can check it. Now here if we look, let's say for the first name information type, there are tons of options, because let's say if my table got credit card values, I can directly select this information type. So I'm labeling or classifying my data, right? Currently if you look, so I've got information type as name here, right? So next, sensitivity level, let me make it confidential GDPR. I can add classification here. Similarly, we can add n number of classification. Let me select another table, employee Cloud Guru Amit. Here we have let's say the sensitive data is date of birth, information type we got here, we have date of birth, sensitivity level as like highly confidential we can give, add classification. Again let me add another classification, last name information type as again name, sensitivity label as confidential, let's say, add classification. So once we are done classifying our like data in the table, we'll click on the save button. Please do not forget to click on the save button. It will give the message successfully saved data classification. You got to see this now we'll go to the overview. So we'll be getting one beautiful donut chart like this. So here we can see name, we have successfully classified it. It shows information, tables containing sensitive data is 2, unique information type is 2, classified columns, since we have classified 3 columns, if you look here 1 2 like 1 2 and 3, that's why it displayed classified columns as 3. And we got 2 tables, one is for employee table and another is for employee underscore Cloud Guru Amit, that's why we got 2. So I hope you got this till now, the concept data discovery and classification, how it works. Now next step will be auditing. So let's go to the auditing tab. Similarly we need to enable Azure SQL auditing. Here if you look, server level auditing is disabled. We'll be configuring this as well, but for now let's enable SQL auditing. Let's tick mark storage, we'll select our pay-as-you-go model subscription, and since we don't have storage account, we need to create one storage account. Let's create new. So if everything looks good, we can click on OK. Alright, it says deployment succeeded. We are good. Now for server level settings as well, it's better to click on the save audit settings, because from my experience I have seen even if you save it it will say the changes have not been saved in the page, right? So again, if we check enable SQL auditing, here we have got the subscription. This time we have got the storage account. Now if you look, we can save the settings. So save operation is currently in progress. It says saving server audit settings. If you look, successfully saved server audit settings. Now it looks good. Let's go one step back. Now let me refresh this thing. So as mentioned, reload site, changes might not be saved, so we need to reload it once again. Yeah, so after reloading, if you check, it says enabled. So this is one trick which I have found from my experience. Now if you here, we got one thing enabled, which is view audit logs. Let's click on it. So we got two types of logs: database audit logs and server log. Currently there won't be any records. Now let me fire these commands. Everything will be audited. Just note it. I'm firing purposely these commands for you so that these things gets recorded. So this let me do some mistakes here as well. Let me make it like date of birth 123 so that it purposely throws some error, right? Now let me do some more maybe create problem. So now under query data, if I try, I'll put some random password. I know it's incorrect password. Similarly, let me put another password. These are incorrect password. Now let me put the correct password, right? So I want everything to be audited. That's why I'm purposely doing these things. So now I put the correct credentials, right? I got my tables listed, right? I can view top 1000, select top 1000. Now let me go back here. So now let's refresh this. See, everything got audited. If you look, right, our database authentication got succeeded, batch completed, right, and database authentication failed. Remember, we have put incorrect credentials, right? So these everything will be audited here. Now let me go to the database audit here and show you, right? So if we look here, what action status are succeeded and what are failed. Since we have put some incorrect values, so it got succeeded. So batch failed, right? Everything got audited. So that what concludes this tutorial. Let me flash the architecture diagram as a conclusion. So we have created Azure SQL Database and SQL Server from the scratch. Then we have enabled SQL Defender for SQL. And then we have classified the data in our table, that is a SQL database. The tables we have classified the date of birth columns, then name column, then last name as PII data, right? We have classified those. Next we have audited basically which users are able to log in, succeeded or or unsuccessful login, those kind of things we can easily track. So thank you so much for watching this tutorial. I hope you found this tutorial for securing SQL database and SQL server as helpful. Alrighty, so let's tackle this question, and as per this question we need to minimize the time required to perform the backup. Let's look at option A. It says log backup. Log backup captures only the transaction log and not the full changes since the last full backup. Therefore incorrect. Let's move to option B. B says full backup. Full backup backs up the entire database and is available for master database as well as per the question. So looks good. We'll park this. Let's move to C and D together. C says differential backup, D says tail log backup. Differential backup and tail log backup cannot be taken on master database. That's why C and D are out, and we will lock option B, full backup, as the right answer. All right now, so here we got a situation where we got to meet the requirements, that is requirements 1, 2 and 3. The solution should be such that. So we'll look first at option A and D together. If we focus on option A and D, both uses to proximity placement group. And if we use to proximity placement group, this will increase latency and complexity by since we are using proximity placement group, right? And as per the question, we need to minimize the latency of database writes. So this does not meet point number 3. So we will reject this. Now let's focus on option B. Option B says create a proximity placement group in an ability set, deploy each VM to the ability set, add both VMs to the proximity placement group. This option ensures the virtual machines are close to each other, minimizing the latency and providing high SLA. Looks good because it meets all the requirements. We'll park this. Let's move to option C. C says create a proximity placement group and 2 ability sets, deploy each virtual machine to a unique ability set, add both virtual machines to the proximity placement group. This option increases complexity without significant benefits over option B. Since for now option B is better than option C, we'll reject option C and log B as the right answer. Okay, so we got a classic Azure database question this time, and this is about automatic failover without data loss in the event of data center failure. Very important scenario with respect to database administrator if you're working in any project. Let's look at option A. It says Azure SQL Database Premium. Azure SQL Database Premium supports automatic failover without data loss and provides high availability as well. Looks good. We'll park this. Let's move to option B and C. B says Azure SQL Database Serverless and C says Azure SQL Database Basic. So both these, that is Azure SQL Database Serverless and Azure SQL Database Basic, does not support automatic failover without data loss, which is the requirement mentioned here if you look. So these two are out. Now let's move to option D. D says all the options. It cannot be all the options because we have already rejected option B and C. So this is also out. We are left out with one option, Azure SQL Database Premium, and it is the right answer. Alrighty, so we got some brainstorming question, and this question uses Azure Shared Disk, and we need to maximize the resiliency. Let's look at option A. It says node majority with a cloud witness. Node majority with a cloud witness is not recommended since it doesn't meet the requirement of using Azure Shared Disk. Therefore incorrect. Let's move to option B. B says node majority with no witness. Node majority with no witness does not provide the resiliency in the event of a network split. Wrong choice. Let's move to option C. C says node majority with a file share witness. Node majority with a file share witness has limitations on scalability and availability. Let's reject this. We are left out with option D, and D says node majority with a disk witness. Node majority with a disk witness is highly recommended configuration for failover cluster instance, that is FCI, when using Azure Shared Disk, as it provides the required resiliency and high availability in case of any failure as required by the question. Looks good. We'll log D as the right answer. Alright, this is pretty straightforward question. As per the question, if we look, the VM1 is a primary replica. That being said, VM2 automatically becomes the secondary replica. Backups on secondary replica can only be of the type copy only, which is option B. Other options uses different things like differential file snapshot and all these, which is incorrect. Therefore, we'll just keep option B and reject others and lock it as the right answer. Alrighty, this is we got to select more than one option. You got to read the question carefully because we need to select 2 correct answers this time. Let's look at option A. A says configure your application from the properties of inventory DB. And if you look at inventory DB, it is nothing but Azure SQL Database instance. So this option does not provide automatic failover without updating connection strings, which is the primary requirement of the question. Therefore incorrect. Let's move to option B. B says add a failover group from the properties of main server. So this option enables automatic failover without updating connection strings, ensuring continuous availability. Looks good. We'll park this. Let's move to C. C says create a new Azure SQL database server named backup server. A secondary server is required to form the failover group, ensuring availability during a regional outage. So this is another potential answer. We got our two answers, looks like. Let's still look at option D. D says configure retention for inventory DB from the properties of main server. Creating another database instance without setting up a failover mechanism does not meet the requirements of meet the requirements for automatic failover without data loss. Therefore, this is out. We'll lock B and C as the right answer. Okay, so we got a disaster recovery question this time, and as a DBA, database administrator, this is very important, we know, in real life projects. So let's tackle option E. E says Azure Database. Azure Database cannot be used for failover and disaster recovery scenarios. Therefore, Azure Backup is out. Let's move to B. B says Azure Information Protection. Azure Information Protection focuses on data classification and protection, as the name suggests itself, not disaster recovery. So this is out. Now let's move to C. C says Windows Server Failover Cluster. Windows Server Failover Cluster is used for high availability on premises, not for failing over to Azure, if you read here, right? So this does not meet this requirement. Let's remove this. We are left out with Azure Site Recovery. We know Azure Site Recovery supports disaster recovery to Azure and provides the ability to test failover without affecting the current environment, which is also the requirement of the question. That being said, option D is the right answer. Let's bring the heat to this now. So here we got a question about low latency requirements for data writes. This is fairly simple because if we focus on option E and B, both uses port number 446, which are incorrect port number. On that basis, we can reject straight away A and B. We got option C left out, and if we look at option C uses asynchronous mode, which is recommended for geographic separation. We got two geographies, right? If you look here, central US and north central US. Since we got two geographic locations or Azure regions, so we need to accommodate the latency and high data change volume, which option C meets. Therefore, let's lock option C as the right answer. Alrighty, so this is all about minimizing administrative effort, which is also a part of DBA's day-to-day activity in real-life IT projects. So let's look at option E and D together. A says Azure SQL Managed Instance. D says SQL Server on Azure Virtual Machines. So both these, Azure SQL Managed Instance, that is SQL MI, and SQL Server on Azure VMs, involves higher administrative effort. As per the question, we need to minimize the administrative effort. Therefore, these two are wrong answers. Now let's look at option B. B says Azure SQL Database Single Database. Azure SQL Database Single Database minimizes the administrative effort and is fully managed, making it suitable for multiple instances across regions with Azure SQL Data Sync, which the question uses as well. Looks good. This can be the potential answer. Now let's look at C. C says Azure Database for PostgreSQL. Azure Database for PostgreSQL is not relevant or is just a distractor because if you look at the question, it uses SQL Server, right? Not PostgreSQL. That's why this due to the mismatch, C is out. We'll lock option B, and before locking, if we focus on the official documentation, it's mentioned SQL Data Sync is a service built on Azure SQL Database that lets you synchronize the data you select bidirectionally across multiple databases, both on premises and in the cloud. That's what we require. And let's lock B as the right answer. All right, now, so we need to migrate two databases to Azure Cloud. So as a database administrator, so these type of scenarios might also happen in day-to-day activities as well. where we need to use our expertise to propose to our stakeholders or business leaders sometimes. Let's look at option A. A says two Azure SQL databases in an elastic pool. Two Azure SQL databases in an elastic pool allows for dynamic scaling of resources based on workloads and also minimizes the downtime during scaling operation. So this looks good. We'll park this. Let's move to B. B says two databases hosted in SQL Server on an Azure virtual machine. So two databases hosted in SQL Server on Azure VMs will involve more downtime during scaling. But as per the question, we need to make sure that downtime during scaling operation is minimized. Since option B cannot meet this requirement, B is incorrect. Let's move to option C. C says two databases in an Azure SQL managed instance. Two databases in an Azure SQL managed instance do not provide the same level of dynamic scaling as elastic pools, what we saw in option A. Since for now option A is better than option C, we can straight away reject option C. Now let's go to D. D says SQL Server on Azure virtual machines. Two single Azure SQL database will require separate scaling for each database, which may result in more administrative effort and downtime. Therefore, we will eliminate D and we will lock option A as the right answer. So please don't go away. Let's meet in next part of this series, which got to be more and more interesting.